In this video, we are going to start and explore pointers, and pointers are one of the most confusing parts of C++, but don't worry, I am going to show you that it is really not that hard if you get the basics right when you just get started. A pointer is really a variable that contains an address of another variable. Let's look at an example here. Suppose you have int variable declared in your C++ program. This is going to be an integer and it is going to be containing a value of 42. And this is how you would declare it in your own C++ program. So num is an integer, and when you do this, your compiler or your computer is going to reserve memory for this variable in your C++ program. And that memory is just going to be an address of where this 42 lives. So you can also declare another variable which is going to be storing this address here, and that's a pointer. So this is the second variable here, which is named PTR, and its value is going to be the address pointing to the location where the 42 integer is stored in memory, if I can say it like that. So you have a variable which contains 42 here, and you have another variable which contains the address pointing to this 42 here. So make sure you understand this. Int is a type, and a pointer to int is another type which contains addresses pointing to integer variables in memory. Make sure you connect these things right from the start here. So we have an integer variable living somewhere in our system, and we have an integer pointer pointing to the location of this integer in memory, and you can see that this address is in hexadecimal here. This is just how these things work. Again, this is another visualization of what we have. The value of 42, its address is 0x7FFE in memory, as you see here. But this pointer is another variable. Because it is a thing that is stored on your system, this pointer also has an address, which is what you see here. So 0x8ABC is the address of this pointer, and these are things you need to keep clear in your mind. The address here contains this integer. This is what we have here, and the address here, the second one, contains the pointer pointing to that integer. This is what we have here. You can read this explanation, and this is how you use pointers in your C++ program. So you declare int num. This is going to be the integer variable containing 42, but if you want to declare a pointer to int, you will use this syntax here. So you say int star, and then you say the name of the variable. This thing we have on the left here is the type. It is a pointer to int, and it is pointer to int because we have this star here. So the star here means that it is a pointer to some type, and in this case it happens to be an integer. Now, when you have a pointer, you have to give it an address of something if you want to assign to it. That's why we have the ampersand symbol here in front of num. This is going to mean that we want to grab the address of num and store that in this pointer. This is the syntax we use to do these things here. So take a moment to make sure you understand everything we talked about here in this slide, because this is really the basic understanding you need to work with pointers in C++. You have a variable, a regular variable really, and that variable is going to have an address. In this case, it happens to be this one, and you can store this address into another variable whose type is a pointer to the type that we have in this initial variable here, and this happens to be an integer in this case. This is something you need to understand. Okay, now that we are starting to talk about pointers, you also need to understand a bit about memory layout. When you build a C++ program, suppose we are talking about the rocket.exe program that we have built. When you compile it, its information is going to be laid out in memory in something that we call memory map. And that's going to be storing information about the memory that your application is going to be using. That memory is broken up into a few parts, but here I want you to focus on the stack, which is a big part, and the heap. The stack is what is going to be storing local variables and function calls, and the heap is something we use if we need additional memory without using the stack here. So for example, if you declare a variable like we are doing here, int num equals 42, this variable is going to be stored on the stack because we declare it like this. But there is another way you can declare or set up variables and tell the compiler that you want that variable to use heap memory. So I want you to understand this right from the start. We have two pieces of memory that we can use. We can use the stack, which is what we have really been using all along. But going forward, because now you have learned about pointers, I will show you that it is also possible to tell your C++ program that you want memory from the heap, and you will be using the new operator, as we will see, but we will see that later. Right now, just make sure you understand this memory map here. It is going to have a few parts. We have the stack, we have the heap, and we have other parts that I don't really want to get into this video, but some are going to be storing initialized data, and some other parts are going to be storing instructions for your code. So this is what you need to know, but the most important parts are the stack and the heap. This is what I want you to keep in mind. Here are a few things about these parts here. So the code segment is going to be storing instructions for your program. The heap is something important. It is used for dynamic memory allocation. The stack is going to be used for local variables, function calls, and things like that. So make sure you keep these things in your mind. Here is a simple comparison between the heap and the stack, and you see that I invested a bit of effort to really make sure you have a good understanding of these concepts here. So that's how important they are. You should really understand the effect they have on your C++ program. Now, the space for the stack is going to be automatically allocated by the compiler, but if you want to use the heap, you have to write your code in a way that you tell the compiler that you want dynamic memory. The stack is going to be a bit faster than the heap, but it is limited, so you are limited on the amount of the stack that you can use. The heap is a bit slower, but you have it in large amounts, so you have access to it. That's why sometimes you need it, even if it is a bit slower, and you can read about all these things. Some of these are not going to make sense right now, but make sure you keep this in mind. As we learn about more things, this is going to become much clearer. But the most important part is that the stack is going to be faster, and it is going to be available in a limited amount. The heap is going to be slower, but it is going to be available in a larger amount. The rest is really secondary. If you understand this, you will be fine with what we are about to do in this course here. Now that we know this, we are going to focus on pointers. Pointers are going to allow you to store addresses of variables. We have talked about that. But before I go further, take a moment and read this warning here. Row pointers should be used sparingly after careful consideration in modern C++. Why is that? Because pointers are the source of a lot of bugs, deadly bugs, if you don't use them carefully. There are facilities that you can use to limit the use of pointers and really get your computer to help you out. Those things are things like smart pointers that we will learn about. We will learn about RAII. Don't worry about this now, but know that pointers are a thing you should avoid in regular C++ development. Use them if you really need them, and you should make sure that you know what you are doing. Now that we know this, we are going to see how you can use them in your own C++ programs. You declare a pointer by saying the type and then putting a star. After that, you specify the name of the variable, and you can initialize the pointer if you want that, which is the recommended way to do things. If you don't put an initializer within these braces, your pointer is going to be initialized with a 0 version of a pointer, and that's going to be a null pointer. But if you want, you can specify an initializer just like we are doing here, and this is going to make sure your pointer is properly initialized. Down here, you see that we are trying to investigate and compare a pointer to things that we already know. So here we are printing the size of an integer. This is going to give me 4 on my system. We print the size of a double. We see what we have. But if you do size of double pointer, this is a double pointer because we have the star here. This is going to give you the size of a pointer on your system. And I am going to clarify something right now. Pointers are going to have the same size regardless of what they are pointing to. Why is that? Because pointers are really addresses. So a pointer is going to have the size of an address on your system. This is going to be different depending on your compiler and your architecture and your processor. But on the same system, pointers are going to have the same size. It doesn't matter if it is a pointer to a double. It doesn't matter if it is a pointer to int. They will have the same size. But I'm not going to print this size and show it to you because this is going to depend on many things on your system. That's something you need to know here. You see that we are trying to print the size of p number 1, and p number 1 happens to be a pointer, as you can see here. So this is also going to print the size of a pointer, and you see we are also trying going to print the size of a pointer to a double that we have on top here. We will try this code and see what we get, and I think it is what we should even do right now before we go any further with us. So let's go to Visual Studio Code. Okay, here I am in Visual Studio Code, and I am going to set up a project. What I am going to do is go into my environment setup and grab my project template. I think I am going to grab everything here except for the build folder because I don't want it. In this case, I am going to grab also the VS Code folder because it is going to give me the configurations I need to do debugging and a few cool things. Let's copy this, and I am going to go up and go to the chapter on pointers and dynamic memory. Let's go into one pointers, and I am going to paste this template code here, and I am going to drag and drop this on top of Visual Studio Code. This is what we always do. I will choose my configuration to be the Visual C++ compiler because I am doing this on Windows and wait for a while. This project is going to be our startup project. We can hit build, or I can even hit F7 on my keyboard. This is going to build, and I can run by hitting Control F5. This is going to run the program. You see that the program has run. You can see it here, but it's not doing anything because we are probably doing nothing in the main function here. So let's go down here in main and clean up a few things to make sure the program is working. We can just use the FMT library. It's not going to hurt. We can say FMT println and then say hello world. Okay, and for this to work, we need to include the FMT library as usual. So let's do that and hit F7 to build. And you see that we have a problem here. What is that? We need to type println properly. I think that's the problem. So let's go there and say println and try to build again. The build is going to be good if we run. You see that it is saying hello world, as you see here. So this is a good starting point, and we can start exploring pointers. Before we even go further, I think we should clarify the map of what we are about to do in this project. This is our map. We want to learn about pointer basics, and we will learn about all these things as you see here. So let's go down and cover pointer basics. Let's go down and put in the code because I don't want to waste your time typing this. I am going to put in the code, then I am going to explain it, but I will do it in parts. So we want to declare and use the pointers. This is what we want to do. And the syntax to do that is int star. And one thing I should say is that it doesn't matter if this star shows up in front of the type or closer to the variable name. It doesn't really matter, or your compiler is going to take it however you do it. So we are going to say int star. This is going to mean that this is a pointer to int. Then we specify the variable name. Then we initialize this. I wouldn't recommend doing things this way. What I would recommend is if your pointer is not pointing anywhere yet, you can specify that by using something we call null ptr. And this is a zero version of a pointer, or a pointer that you have stored in your program, but it is not pointing anywhere yet. Later on, you can decide to make it point somewhere, but right now it is not pointing anywhere. And we say that using null ptr as we are doing that here. Now that we have this pointer declared, we can try to dissect it and see how it behaves or how it compares to things we already know. So we print the size of an integer, we print the size of a double. This is something you already know, but we can also print the size of a double pointer. We will see how big it is. We print the size of an integer pointer. We will see how big it is. We can also go through the variable names for these pointers and print the sizes, and we want to see how this is going to behave. So let's try and pass this through the compiler. I will hit F7, but if you want, you can also hit the build button down below here. This is going to do the same thing, but it is faster to just hit F7 on the keyboard if you are using Visual Studio Code like we are doing here. So hit F7. This is going to build your program. Another thing you can do to run the program faster without taking your fingers off the keyboard is to do Control F5. This is going to run without debugging. I think we have that option somewhere. Run without debugging. So if you want to run your program, you can go to run and hit run without debugging. This is going to run the program. program, you see that we have the output here. But sometimes I find it faster to just use these shortcuts that we have here. This is going to save us some time. Okay, so if you hit Control F5, this is going to run the program. Let's do that. Control F5, and the program is going to run. Let's close it. So we can close this terminal containing our program, and we can hit Control F5 again. This is going to run the program. Let's analyze the output here. So we have the program, and down here we have the output. I don't want you to lose sight of that. We have the hello world message that we printed earlier that we should really take out. It is not serving any purpose now. So let's go down, and we should align these things properly. So let's go down and do that. Okay, now this is aligned, and we can look at the output we have here. So we declared the integer, pointer, and a double pointer, as you see down below here, and we try to print the sizes of these things as you see down below here. So the size of an integer is 4, the size of a double is 4, but you can see that the size of pointers on my system or the size of addresses on my system is 8. It doesn't matter what the type we point to is, any address is going to have 8 bytes on my system, and this is something really cool to know. So what I am going to do is move the code for these pointers in its own module. In this case, I want you to try and separate things in different modules. So what I am going to do, I am going to create a new file in my project. So let's go here and say int_1 ixx. This is going to be a file storing our first module exploring pointers in this C++ project here. Let's hit enter. The file is going to be created, and I am going to make it a module. So module, and we want to export module, and say int_1. This is going to be our module, and then our code is going to be put down in our module purview. So for example, we can also put information about this module here. Let's say that we are exploring the basics of pointers, and we can go down and set up the function. So export void. Okay, this is something we can do, and we can move all that code in this new module here. So let's go back and go into main and grab the code. We can grab everything, go down and copy, and then we can hop over into int_1 and paste it down here. It is going to be part of this module. Now I want you to try and make this code work. Try to think about what we can do to use this function that we have here, because now as you see, we have the main file, we have the utilities file that we had, but now we are adding another layer. After the utilities, we are adding a few other files. These files are meant to be used inside utilities, and utilities in turn is going to be used in the main file. This is the structure we have here. Another thing you should not forget is that we should go into the CMake lists.txt file and account for this module file that we are adding here. So go down here and add it. We should say int_1, and it is ixx. Let's give this a good build and see what we have. We can hit F7 to build, and it is going to complain that we don't have FMT included in our new module. So let's go there and do that. You know where to put your includes. It is in the global module fragment. So let's go down here and do that. So FMT format, and I will give this a good build to see if the error goes away. You see that the error is gone. Now we can build our project. Now we have the thing available inside this module. We should go into utilities and import that module, and your import statements are going to be shown down below here, below the module declaration line that we have around here. So what I am going to do, I am going to say import pointers_1. This is what we want to import, and we are going to rename this file here. So go with me. This may introduce problems, but we need to name things properly, at least I think. So pointers_1, and we need to name the module. Let's go down here. It is going to be pointers. Let's do pointers_1. We need to change that here. We also need to go in the CMake list.txt file and change that. Let's do that. So pointers_1, and let's wait to see if this goes through. The build files have been generated. We can build, and now the build is good. So let's go into pointers_1. We have the function here. It is exported, and anyone who imports this module should have have access to pointer declaration initialization, the function we have here. So we can go here and set up another function. So let's say export void and say pointer basics. And this function is going to be calling that function that we set up here. So we can put it here and call it and give this a good build before we go on. If we have a problem, we will fix it. Right now, I want you to understand what is going on because it may be confusing. Again, we have the main file, which is where our program is going to start. We have the utilities file, which is going to be an intermediary. And then we have our other modules that are going to be doing the heavy lifting. And one of those modules is pointers _1 that we have. It contains the pointer declaration and initialization function. That function is imported in utilities and we are calling it down here. You should make these connections in your mind. Now what we want to do is call pointer basics and use it to do things in our main function. And we will do other calls to the functions that we have in other modules that we will set up. But maybe I am confusing you here. Just follow what I do and try to make sure that you understand what is going on. Now what we want to do is to call pointer basics in the main file. The main file is already importing the utilities module. So let's go there and then say pointer basics. And if we give this a good build, hopefully the build is going to be good. If we run the application, we will see our output here. Now we have organized our program in a way that we can add other modules and really separate the way things work in our C++ program here. This is how you declare and use pointers. So again, make sure you understand the syntax. Now we are initializing and not making the pointer point anywhere. Explicitly, it is going to be pointing to a null pointer, and null PTR is a thing that tells the compiler that your pointer is not pointing anywhere. Another thing you should take out of this lecture is that pointers have the same address. It doesn't matter. Pointers have the same size. It doesn't matter what they point to. So if it is a pointer to an integer on my system, it is going to have 8 bytes as we saw. If it is a pointer to double, it is going to have 8 bytes. Addresses have the same size on the same system, but they may differ if you are on a different system. That's something you should know about C++. Now that we know this, another thing I want to cover in our pointer basics is putting data in a pointer and getting that data back. So let's say assignment and access, that's what we want to do. And I am going to set up another function to do that. So let's say assignment and access. This is going to be our function here. And we will initialize a pointer and then store an address inside of that pointer. Again, I am going to put in the code and then clean it up. Okay, let's do that. We know that pointers store addresses of variables. So what we are doing here is setting up an integer int _var, giving it a value of 43. And then we are grabbing the address of this integer using the syntax here and storing it in this pointer variable that we are setting up in our C++ program. What we can do now is print this information. So what I want to do is go down and say, and we want to print our int var. The value is going to be put in a placeholder that we put here, and we will put that value into here. So int _var, that's what we have. This is going to be printed. This is nothing you haven't seen so far, but what we want is to print the address of this thing and see this address printed out in our program here. So let's say fmt println, and we can say address of int _var. I think this is going to be descriptive enough, and we will put that in this placeholder. And what you need to do with fmt to print an address, you use a facility named fmt : ptr. This is going to be printing pointer addresses, and you specify the pointer variable whose address you want printed, and it is our pointer to int, so we can put it here, and this is going to print our address. Let's try and pass this through the compiler. We can hit F7 to build to see if it even builds. The build is good. Another thing we can do, now that we have built this, we can even walk through this using a debugger, but notice that this is a function we have set up. We haven't called it yet. We need to go in our utilities module and make sure this function is called. If you run the application now by hitting Ctrl F5, this is not going to do any more than we did in the last iteration of this video. So we need to go into utilities and update things that we are doing. So let's go down and we can go back and grab the function name that we set up here and make sure that it is called in our utilities module. So let's put it down below here and call it, and then we hit F7 to make sure we can build. The build is going to be good. Now if we run the program, it is going to say that int var is 43, which is what we are doing in our program. Let's make sure you can see this. Again, another thing you can do within Visual Studio Code is make sure the function is selected. If you hit F12, you will be taken to the location of that function in your project, and this is something really cool. You see that Visual Studio Code is even going to take us from one file to another. This function is defined in pointers_1, but you may not have that information at your fingertips, and if you hit F12, you are going to be taken into the file where that function is defined. This is something I use a lot in my C++ project. So you see int var is defined. We store the address of it inside of this pointer that we have here, and then we are printing this information. Int var is going to be printed. You can see it down here, 43, and the address is going to be printed as what you see here. Please note that this address may change as you run different iterations of the same program. So if we hit Ctrl F5 to run it again, this is not going to run it, but we can close this terminal and run it again. The address is ending in 64. Let's try to hit the run button here to see if we run it different times. You see that every time you run the program, the address of this variable is going to change, because every time you run the program, the operating system is going to give you different pieces of memory. You can think of your memory as a long piece of memory like this. Sometimes when you run the program, you are given this location. You run it again, you are given this location. You run it again, you are given this location. So where your variables are going to be living is not under your control. The operating system is going to give you memory that it has available. That's why these addresses are different. This is something I want you to know. Another thing you should notice is that you can walk through this using a debugger. So we can just go to run and say start debugging or hit F5. I am going to do start debugging, and this is going to just hit my breakpoint. You can see that in my locals, I have my variable int_var, which is not initialized yet, but we can step over, and you step over by just hitting F10 or hitting this button here. So I am going to hit F10 on my keyboard. If I do that, you see that int var is initialized already. So this is cool. And the pointer is not initialized yet, so we can't see any information in the debugger here. But if we hit F7, the integer pointer is going to be initialized. The address is going to be this one you see here in the debugger. So FF694 is going to be the end of this address here. You can see that it is hexadecimal, and the debugger is showing us that in this address we have a value of 43 stored, and this address is where this integer variable is living. I really want you to understand these things here. So next, we don't do anything special. We just print the information. We hit F10. We are going to print 43 contained in int var, and if we step over again, you will see that the address is going to be printed out. And take care to notice that this address is what we saw in our debugger. This is something you should notice. The end is FF694, FF694, FF694. So we have the same information, and this is really cool. Let's stop debugging and keep working on this. Another thing you can do is change the address stored in a pointer. So let's go down and give you an example of that. Okay, what we have here is another integer variable named int_var1, and we are storing the address of this new variable in our pointer variable that we had on top. So what this is going to do is going to change the address that we had and store this new address in our variable. And if we print the address contained into this pointer, we should get a new address. This is something you can do in your own C++ program. Again, we can pass this through the compiler to make sure we didn't introduce any error. The build seems to be good, so we can hit F5 to work through this using a debugger. Our breakpoint has been hit. You can see that we have two variables now, int_var and int_var1. They are not initialized yet, but we will initialize them by hitting F10 and walk through the program. Now you see that the pointer currently contains the address of int var. You can see it here. The address is ending in C44 and the value inside is 43. This is what we have here. But let's go down and print the information. So we can hit F10. This is going to be printing the information. Now we go down and initialize int var1. At this point, notice that it still contains a junk value, but if we step over, we will initialize it with 65. And what we want to do is to change the address stored in our pointer to integer that we have here. So it is a new address that we want to put inside. If you wanted, you could have grabbed the address of int var1 and stored it in a variable, but we don't want to do that. We will just put it in this pointer and then print the address that this pointer contains. This is going to show you that you can change the address stored in a pointer anytime by using the syntax that we have here. So let's step over and you see that the address is going to change to something else. And if you print it, you will see it shown on your terminal. Now you see that the addresses are going to be different. The address was FFC44. Now it is FFC64. This is a new address pointing to the new location that we are pointing to in our C++ program. This is really cool. Another thing I want you to see is that you can't cross assign between pointers pointing to different variables. And what I mean is, for example, we have an integer pointer and we have a double pointer. And if you try to take the address of a double and store that in a pointer to an integer, you will get a compiler error. So you can't really combine this. A pointer to integer is going to be storing addresses for integers. A pointer to doubles is going to be storing addresses of doubles. If you cross and mix these things, you will get compiler errors. That's what I want you to see here. So I am going to uncomment this line and show you that this is going to give you a compiler error. I want you to be aware of this. I stopped my debugging session here because it was still running, and I can hit F7 to try and build this program. If I do that, we should get a compiler error. And let's go through the output here and see what the problem is about. Cannot convert from a double pointer to int pointer. This is what we are doing here. So we want to take a double pointer and store that into an int pointer. And to do that, the compiler would have to take this double pointer and transform it into an int pointer, but it can't do that. And you see that this is what we are complaining about here in our output. So you can't really do that. And I want you to be aware of this. The last thing I want you to see in this function is that you can dereference a pointer and print the value that it is pointing to. Here is a piece of code that is going to try and exemplify that. We have an integer pointer declared here, p_int2, and it is not pointing anywhere at this point here. This is something I want you to see. Then we declare another integer variable, int data. The value is 56, and we make this pointer point to this integer variable using the syntax here. This is what we are doing here. At this point, p_int2 is pointing to int data, and int data happens to contain a value of 56. So what we want to do, sometimes you want to go through the pointer and access the pointed to value. And the syntax to do that is to put a store in front of the integer variable. When you do that, you are telling the compiler, I don't want to access the address in the pointer. I want to print the thing living at that address, if that is making any sense. So if we do what we are doing here, this is going to be printing the value inside the int data variable, and we will see a 56 printed. And in this case, we are dereferencing this pointer here. Again, suppose we have a variable containing 56 and we have a pointer pointing to it. This is a pointer. And we go through the pointer and print this 56. And to do that, you just put a star in front of it. I really want this to be very clear. Let's pass this through the compiler to make sure we have no boo-boos. The build is going to be good, hopefully. The build is good, and I don't think we need to work through this using a debugger. But we can just run by hitting Ctrl F5. This is going to run the program. And we will see a few things printed out here. The last one being value 56. And it is this thing we are printing here through this syntax this is going to be accessing the value stored in this pointer. That's something I want you to know. Okay, this covers everything I wanted you to see about assignment and access. You can declare a pointer and make it point to somewhere using the syntax we have here. Notice the ampersand symbol. This is going to be grabbing the address of a variable and storing that in a pointer. And you can print the address of a pointer using the syntax we have here using the FMT library. Okay, at this point we have the address stored in this pointer. You can change the pointer to point somewhere else using the syntax here. You can't cross assign between different pointer variables, and you can dereference a pointer using this syntax here. This is something I want you to know. In this video, we are going to explore pointer to characters. And a pointer to a character is nothing different from what we have seen before. The only difference is that the type that we are pointing to is a character. And here I have a simple example of an array, and this is not random. There is a reason for this. So when we set up a row array, for example, storing a bunch of characters, and we put in the data that we have here, the name of the array is a pointer to the first character. This is something I really want you to know. What this means is that you can use this name of the array where a pointer is needed, and this is going to come in handy sometimes. Another thing I want to point out is that a character array can be directly printed out using printing facilities like stdcout or the format library. Let's look at an example. I think this is going to be much more clear. Here we have a simple program that we are about to run, and you can see that we can declare an array using the syntax we have here. If we say char star message, this is going to be a pointer to a character, and we make it const, meaning that this string of data is not going to change. When we do something like this, now we have a string or an array of characters stored in memory, and the name of the array can be treated as a pointer to the first character in this array. And this is going to allow us to navigate through the array easily using things that we are about to learn about in this chapter. What I want you to see here is that you can declare an array like this, and that this is a pointer to character, and the message is going to be a pointer to the first character in the array. This is what we mean here. This is not specific to arrays of characters. The name of the array is always going to be treated as a pointer to the first element in the array, but character arrays are special in that they can be printed out directly using printing facilities like the FMT library or stdcout. So this is what we have here. Because this thing is const, we cannot modify it. So you see down here, we are trying to dereference the pointer and then assign a value to that. If we try to do that, this is not going to work because our array is const, as can be seen in our declaration here. This is something I want you to see. If you want to print the address of the character array, then you need to use this syntax that we have here. This is going to tell the FMT library that we want to print message as an address and not as a string. By default, it is going to be printed as a string if you print it like this. We are about to see this in Visual Studio Code, but I just wanted you to see this in a slide so that you know what to look for when we get to do this within Visual Studio Code. Another thing you can do is declare your array using this syntax here. And when you do this, the array is not going to be const. We can go through the notation we have here, the square bracket notation, and modify the element in the array. And if you print it, you will see that your changes have been applied. So this is really a small aside to show you that character arrays are a bit special. They are special in that if you print the name, this is going to be understood by the printing facilities like the FMT library because they basically see that it is a character array. So it is going to loop through the array and print it because it is a string. It is meant to be read by humans. But if it is another array, another type of array, for example, an array of integers, if you print it like this, this is not going to work. Another thing you should drill in your mind is that the name of the array can be treated as a pointer to the first element in the array. Now that you know this, we can hop over to Visual Studio Code and see this in action. I think we will still go in our module that we have here and then set up the function to play with us. Let's do that. Okay, this is going to be our function, and I am going to put in the code so that we can move a bit faster. We want to explore a pointer to characters, and you can declare a string of data using the syntax we have here. Again, you say char pointer. So this is a pointer to car, and we initialize this with a string nested within double quotes as you see here. What this is going to do, it is going to create a string in memory. It is going to allocate space on the stack. I want you to keep this in mind. This is going to be living on the stack, and the message is going to be a pointer to the first character in the array. And when we do this, we reserve the right to navigate through this array using this pointer, using mechanisms that we will see later on in the chapter here. But right now, just note that this is an array of characters. Because it is an array of characters, we can print it using the FMT library or stdc out. I think we can even go on top and include stdc out. This is not going to hurt, so let's do that. IOStream, it is what we should include. And if we go to the end, we can say stdc out. Okay, this is also going to come out and be printed. We should use \n as the new line character. If we pass this through the compiler, let's see what happens. The build is going to be good, and we should go in utilities and call the function we just set up. And to avoid the typos, I am just going to go back and copy the name of the function. This is going to be just easier. So let's go there and go back into utilities and call that function here. I am going to put the name in place, hit F7 to build to make sure we don't have any boo-boos. And we have every other function commented out. So if we run this, I am going to hit Control F5 to run the application. And notice what we have in the output. I want you to understand what is going on. So let's go back to our function where we put the code. The first line is saying fmt print ln, and we want to print message. If we do that, this is going to give us the entire string. Notice that we are passing message, but this is going to print the entire string. This is the default behavior of the FMT library. Notice how we defined this string here. The syntax is what we have here, and I want you to notice that this is just an array of characters stored in memory, and the memory where this lives is the stack. Don't lose sight of that. So this syntax is going to give us what we have here. The second syntax is basically dereferencing the message pointer, and you may expect this to print the entire string, but this is going to print the first character, because when you do this, the FMT library is going to understand that you're not interested in the entire string, you just want the first character, because message is just like a pointer to the first character in this array here. If you go down and use stdc out, then we will print the message again. So the entire string is going to be printed out. And there are ways you can force this to print the address, but I will put that in another project which is specific to stdc out, and I am going to put the link in the resource section of this video here, so you can check that out if you are interested. Now that we have this, we should see that you can't modify this string in any way. If you try to do that, you will get a compiler error. And why is that? That's happening because we declared our character array as const. So let's go down and show you that we can't modify it. Now the syntax we have on line 70 here is trying to dereference message, and remember that message is a pointer to the first character in the array. The syntax we have here is basically saying I want to change the thing that my pointer points to, and in this case message is pointing to the first character in this array, which happens to be h. You can see that at the first index we have h, so if we try to modify it, we want to change it to be a b so that the message becomes below world, but this is not going to work because we declared our character array as constant. So let's pass this through the compiler to make sure you see the problem here. This is something many people do, and it is easy to be thrown off guard. So you see that the compiler has declined, and it is saying there is no context in which this conversion is possible. Pointers IXX line 70, this is the problematic line, but you see that the real problem is that we cannot convert from const car to const car. So basically the problem is that this array is const, and we can't modify it this way. Now some of you may think, what if we remove the const that we have here? Let's try it, and we can assume that this is going to build and allow us to modify our character array, because we are not making it const now. Pass this through the compiler and see what happens. It is really good to try and experiment. And to your surprise, this is not going to work. Try to think about why. I am going to give you a second. And if you didn't get it, don't worry, that's not a big problem. But the problem is that the hello world string we have in here is a string literal. So a string literal is const by default. Remember that a string literal is going to be burnt into memory. So it is going to be basically burnt into the binary that you generate when you compile this application here. So it is const, and the compiler is basically telling you, you can't take this thing which is a constant naturally and use a non-const pointer or a pointer that we could use to modify this thing which is not modifiable in the first place. So a string literal is constant by default, and we can't set up a pointer which would allow people to modify things. So the problem is basically not here on line 70. I am actually going to comment it out and show you that the problem is not on line 70, and I am going to try and compile the program, and you see that we still get a compiler error. So the problem is on line 64, and it is that we are contradicting ourselves. A string literal is const by default, but the pointer we are attempting to set up here could be used to modify this thing which is non-modifiable by nature. So the compiler is stopping us from doing this. So we really have no other way other than keeping this thing const. At this point, the compiler is going to accept it because this string literal is non-modifiable. So if we pass this through the compiler, the build is going to be okay. You can see that the build is good. But if we try to modify it again, this is not going to work because it is const. The const here means that we can't go through this pointer to modify the data that is in this character array. Make sure you understand this. This is something I wanted you to see. Make sure you have this drilled in your brain. The next thing I want you to see is that if you want to print the address and you don't want to print the entire string, we can use this syntax that I am about to show you here. So let's go down and put it in place. Okay, this is the syntax you use. You say fmtptr and then you pass the message array. This is going to print the address of the array. Let's try and pass this through the compiler. And if we run this, this is going to do what we need to do. It is going to print the address. And if you run the application multiple times, chances are that this address is going to be different. But in this case, it seems that it is the same address. Let's close our terminals here and try to run it again and see what we get. So we get the same address, but this is not guaranteed. Because as I said before, when your application runs, you may be given different memory locations in the RAM. At one point it may be this location, at another point it's going to be another location. So it is not guaranteed that this address is always going to be the same, but in this case it seems that it is the same. So now we have this done. Okay, now we have seen that you can set up a character array using the syntax here, and this is going to make sure you can't modify the data of your array. What if you want to modify the data? What if you want this kind of syntax we have on line 70 to work? Well, you can declare your character array as an array and not use the syntax that I have shown you earlier. So this is the syntax we will be using. And you see that we say car message. It is an array. We specify that explicitly here. And then we put our string literal in here. The compiler is wired in a way that it is going to understand that this is a regular character array. In some sense, we want to treat this as an array more than a string. This is how I understand this. And if you do this, you will be allowed to modify the array using any syntax you have. You notice that we are using array syntax to modify this. So if we do this and pass this through the compiler, the build is going to be good, at least I hope. So let's make sure the build is good and you can run the application. If you do that, you will see this thing printed out here. What we will print here is hello world because we have changed the first character from H to B, as you can see here. I think we can even use the debugger to work through this. It's not going to hurt. So let's make sure we have a breakpoint on line 77 and a build to make sure we have the latest changes. I am going to hit F5. I don't know what happened there. Let's hit F5 again. Now we will hit the breakpoint and you can see the data we have here. So message contains hello world and you can see everything broken down here. The address of this array is this thing you see in memory, and the address of the second array is another location. At this point you see that message 1 is not initialized yet. So we just have it described, but it doesn't have any data yet. This is what we have in memory. But if we step over by hitting F10, you will see that the array is going to be set up and it is going to be containing the data hello world. Now what we want to do is to modify the first character from H to B, and if we execute this line, that's going to happen. Let's come back here and execute this line. You see that H has changed into a B. I want you to notice that right here, and if we print it, it is going to print below world. So let's do that. You see that it is printed out here, and it is the same thing we have in our output terminal here. So this is something you can do, and I really want you to understand character arrays are special. You will see them a lot in C++, but the version we see a lot of is the syntax you see here, especially if you are interfacing to things coming from the C programming language. This is something that is used a lot in the C programming language, but in C++ you shouldn't really define strings like this anymore. This thing is referred to as a C string in some terminology, so keep this in mind. If you hear somebody talk about a C string, they are talking about something like this. Another thing I think I should show you is that we can also use the array, we can also use the pointer dereference syntax to modify this. I told you that the array name can be treated as a pointer to the first character. So what if we tried to use the dereference syntax and not to go through the square bracket notation as we have seen here? We basically want to use this syntax on this second array here. So let's go down and do that. We can say message1 or dereference message1. Okay, this is what we want to do, and say it is equal to B. And I want you to try and think about this and try to guess if it's going to work. Let's pass this through the compiler, and the build is good. And if we run the application, this is going to give us our output here. This syntax is going to work. You can see that the array name in most cases is going to be almost similar to a pointer to the first character in your array. You can see that in most cases you can treat the array name as a pointer to the first element in your array, and this is really what I set out to show you in this section of the video.